Back, everybody. So we're going to look at the group with next and finish out the G's. I might do a separate video for greater than and stuff, but we'll see. So this one is a list function. Um, it's got to be somewhat similar to group by, but group with. So we'll start with the type signature this time. So this one takes a function that takes two A's and returns a Boolean. So that's the first thing. We're not returning a key, returning either true or false. And we pass it a list of A's, and then we return a list of A's. Okay, so this takes a list and returns a list of lists where each sublist elements are all satisfied pairwise comparison. Interesting. Okay, let me start over. It takes a list and returns a list of lists where each sublist elements are all satisfied pairwise comparison according to the provided function, which is this predicate function. Only adjacent elements are passed to the comparison function. So it feels like sort of like reduce, where you're passing the previous value and the next value. So I'm gonna assume that if you have a list of look at this one, 0, 1, 1, 2, 3, 5. The first AA would be 0, 1. The second AA would be 1, 1. The third one would be 1, 2. That's just what I'm assuming without having looked at it. And if we expand the parameters here, so this function for determining whether two given adjacent elements should be in the same group. Yeah. So a predicate function based on two elements in the array that are next to each other. And then the list, the array to group, also accepts a string, which will be treated as a list of characters, which I think is awesome that Ramda does treat strings like arrays of characters. Um, and then returns a list, which is a list that contains sublist of elements, a list of lists, whose concatenations are equal to the original list. That's interesting. So let's look at this one here. We do something. We get 0, 1, 1, 2, 3, 5. And it says if you concatenate this, or I guess flatten this list, it looks just like the original list. So 0, 1, 1, 2, 3, 0, 1, 1, 2, 3, 5, 8, 13, 21, 5, 8, 13, 21. Okay. So it's not filtering the list, giving us back the same elements in the list, just grouped together based on the predicate. Cool. So we're gonna need a list of lists. I think I have that here. No, we don't. We just need a flat list. So let me use this one, but looks like all of our lists in the input here have duplicates. So let me do that. Let me put in another 2 and another 4 and a 6, another 6, and a 7, and an 8. And another 8, because I'm just feeling like that today. So that'll be our data. And in fact, I'm going to grab this data, move it down here so it's closer to what we're working with. All right, so we got r dot um, group width, and the first argument is that function. So it takes two A's. Yeah, yeah. Let's call it A. We can't say A and A because that's the same thing. So let's just say A and B. We need to return something. So what if we say if A equals B, like if they're the same. And then the second argument is going to be our x's. Let's see if I did that right. Yeah, it looks like it. So we've got a list of lists, right? So here's our outer list and then our inner lists. Um, yeah, and so the first one is one, and then it puts the duplicates together. So that works. So yeah, I mean it's pretty simple, I think. I don't really know what else to do with that. Now in their example, yeah, I said if it equals, so we could do r dot equals. That would be like a, in fact, we don't need the parameters because it's automatically receiving, the callback function automatically receives two adjacent elements at a time. So we could just clean this up, put it all in one line. That should give us the same result, and it does. Uh, what if we did not equals? So equals is not a, it is a function. I always forget if I should use negate or not. Let me try negate. I'm going to negate the result of this predicate function, clear that, and I get an error. Let me just guess. I don't understand that error at first glance. Yeah, still get an error here. R dot not equals. Let me try this just manually doing it again here. Go back. Yeah. So let's say A does not equals B. That should work. Yeah. Yeah. So we get a one and a two and a two, three, four. That's interesting. Yeah, because they don't equal each other. So one and two, and then the next one, two and two equal each other. So it starts a new list. Two, three, four, and four and four equal each other. So it starts a new list. Yeah. But why couldn't I do not equals? I mean, there is a negate function, right? We haven't gotten to it yet, but I don't know why it does that when I'm zooming in. Negate, negates its argument. Okay, that's not what I was thinking. So maybe it's called not. Function that returns, yeah, it should be not. I should be able to say r dot not, r dot equals, but I get an error. Maybe it is because it's taking two arguments in the callback function. That's just a guess. Will return true when passed falsy values and false when passed a truthy one. Or maybe it's this. Maybe I have to negate the whole kit and caboodle. R dot not. No, no, that didn't do what it is. So I don't know why I can't negate um the predicate here, the r dot equals. I don't know. If somebody knows, leave a comment. Um, I'm not going to worry about it too much because we'll get to not eventually. But let's go back to the function at hand, which is the group eyes. Let's eyes h. Yeah, and there's no c also. So that's group with. And I don't feel like this is taking too long, so I'm going to go ahead and just knock out the g's, do greater than and greater than equals because that looks super simple. Let me clear that out. And so now this is about greater than. So this is a relational, both of these are relational ones. And I mean, what it is, greater than, it's that, and the greater than equals is this. Um, my font, Fear code, is combining those two elements, but it's the equals or the greater than and the equals with no space, like that. So just as a function. So we could say r dot greater than 3 and 4, and that's false 3. Now wait a second. I get confused because of the order. I'm thinking I would say is a value greater than 3, and then I pass 4, and I would think that'd be true, but it's backwards. Okay, so now I need to read. Returns true if the first argument is greater than the second. Well, I mean, there it is right there. False otherwise. And it says also less than. Yeah, we'll look at less than equal too. Okay, so the order is a little different. So this is when it becomes really handy to do something like this with the placeholder, underscore, underscore. So now, let's see. So now I've got this function. Let me say const is greater than 3, right? So the first argument is greater than the second. And then I'll put this up here. And then say it's greater than 3, 4. And I get, oh no, it's backwards again. I get so confused with these and the order. So is returns true if the first argument is greater than the second. 4 is greater than the second argument, but I'm getting false. So there's something I'm not understanding. Instead of doing, okay, for some reason, I'm always second guessing the calling it like this. What if I call it like that? Now I get true. So there's something about curring using this placeholder that's not right, or not the way I'm thinking it is. Let me try another version here where I r dot flip the arguments or r dot greater than. But I have to pass it a value. So 3. Let's see what we get and then work out the logic. Okay, so now I get true, and that's what I want. So if the first argument is greater than the second argument, and I'm passing the second argument here because of flipping the function. So I'm creating a function that is greater than 3 and then passing to it. So like if I do 2, we should get boss, and we do, right? Okay, so let's look at the type signature here. So we have another type constraint. where A is part of the ordered type class, I guess. It's basically saying like there's a bunch of there's a something called orderable, like something's orderable, like numbers are orderable and strings or characters are probably orderable based on the order of the alphabet, and decimal numbers are orderable, but like true and false, I mean, they may be because they could be coerced to numbers. Um, like symbols are probably not orderable, objects are probably not orderable. There's probably a list somewhere. I don't really feel like looking up, but anyway, knowing that A must be something that's orderable and numbers are, um, we pass in two numbers and we get back a Boolean. Pretty simple. So yeah, yeah. Okay. So then there's less than, right? And I'll just change that to less than. Save that. So before I run it, let's compile it in our heads. So we're flipping less than three. Let's just go here. Same type signature. Returns true if the first argument is less than the second. So the only difference is the word less. And we get, let's see, we're flipping if the first argument is greater than the second, but we're flipping it. So we should say if the second argument is greater or is less than the first, the second argument is less than the first argument. We're passing the second argument here because we flipped it. So this will be the first argument. Is the first argument less than three? And it is. So we should get true. And we do. But if we didn't flip it, now we're saying if returns true if the first argument is less than the second. That's the first argument. This is the second. Oh, and we get false. But if the first argument three is greater or it's less than the second argument, we get true. And then less than equal LTE. We run that. We get true. We run two and we get false. Oh, what did I do? Oh, it happened. Let me rename this. Less than or equal to three and less than or equal to three. All right. So we get false, but it's less than or equal. So if we did three, we get true. And bam, there you go. So no huge mystery with that. The only thing that I find a little bit confusing with these greater than or less than or equal is the order. Same thing with subtract and divide. I mean, the way I usually figure it out is give it my best guess and then reason about the output, make sure that it's correct. What I'm expecting. If not, just flip the arguments around and Bob's your uncle. So we go back to greater than. We've done greater than equals, and let's just look at the examples one more time. We've got greater than two, one is true, so two is greater than one. Two and two are the same, so it's false. Two is not greater than three. Yeah, in my mind, like if I was going to create this function, I probably would have flipped these two arguments, but it's one or the other. I don't know why Boolean logic is so confusing to me, but it can be mind bending really quickly. Um, But yeah, that's greater than and greater than equals. And again, it's just the function version of the operators that are built into JavaScript. Um, and if you didn't know, the operators built into JavaScript are functions. They're just functions. You could do like add two and three, or you could do in some languages the arguments and then the function name, and then in some infix notation. So this is infix notation. Of course, it would look like in valid JavaScript, it would look like this. But some program languages do have, like in JavaScript, um, two and three, or two and three. That's how we do it. That's prefix notation. And this is infix notation. But the plus operator in JavaScript is actually a function. That's how it's implemented. And then I think there's a program language called R. You don't wrap the values, you just put them in there like that. And this is called postfix notation. And there's a companion library to Ramda called Sanctuary.js. I'm going to look at that after I complete this series, like in the year 2032 or something. Uh, but the syntax for calling a function is more like in Haskell, which would look like this. There's no parentheses. You don't need parentheses to invoke a function. And every function takes one argument. Everything's curried by default, whether you want to or not. Uh, but obviously, this is not valid JavaScript syntax, but you can do it like this. And I actually find this very nice to read. Um, and my prettier doesn't want me to do it. But if I look at this, I'm just trying to remove the parentheses in my mind, and then it looks just like Haskell, and it's just so concise. And in Haskell, you do use parentheses, but just to group things together. Uh, like when you're evaluating expressions, like if you remember the "Please excuse my dear Aunt Sally" for parentheses, exponential, please excuse, multiplication, division, addition, and subtraction. That's the order of operations. And so in Haskell, you would just use the parentheses to group things together, so that it doesn't, like this. You could say subtract two. The add takes two arguments. This is the first argument, and this is the second one. But we're applying subtract. Um, well, we need an argument. You could say subtract. Now I'm confused about the order, and I'm on a sidetrack anyway. But assuming I'm correct, we can say subtract. I think this is saying subtract two from one. But anyway, you would do this calculation, and then you would need parentheses here, and then like this is the first argument to add, and this is the second one to add. So that's the way Haskell syntax looks like. But if you wanted to mimic that in JavaScript, you could do like this with spaces. I quite like that. And then if we did want to apply a function to the first argument, assuming we had let's do multiply. I don't have to worry about the operations. We could do something like this, and that should be right. Just for fun. This doesn't work, I'll leave it alone, but let's just log that and see if that would be valid syntax if we use the Ramda versions of it. So we'd say r.add, r.multiply, r. Dot add, r. Dot multiply. 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 R. D Yeah, let's see if that works. Yeah, and it does. So, I would even go as far as putting space here. So what we're doing is we're multiplying 2 times 3, and that gives us 6, and then we're adding 6 and 3, and then we get 9. So in my own personal projects, I've been kind of doing this, and I find it a lot more readable because when you're using parentheses and nesting things, you do, let's just say, no, prettier would clean it back up. But that gets a little hairy because you've got these parentheses, like here's 3 parentheses together, and it takes a little bit of time to parse. So yeah, going forward, you might see me write it in more of the Sanctuary JS slash Haskell-ish way. But on that note, we're done with the F's and the G's, and we've looked at the less than and less than equal as well. And next, we're going to be starting in on the H's. And if I look here, trying to see how many we have, like tons of I's. Yeah, we only have 3: has in, has path, and head. Head is very simple. I'm not sure what these 3 are, but we'll figure it out when we get into the next video. So thanks for spending your time with me. Tell a friend, and I will see you when it's time for the H.